Okay, we are in the 427 YouTube homework for cell communication. Let's go ahead and go over how this was scored and if you earn points or where you missed points. If you're curious how you missed them, go over that. Question 1 gives us a diagram that you guys have all seen because you had it on a test before. It says, the figure above represents a generalized hormone signaling pathway. Briefly explain the role. Explain, right here, the word, very important, explain. Doesn't mean state, it means explain what's happening. In each of the numbered steps and regulating gene expression, okay? So gene expression means formulating a gene. Okay, so for step 1, the hormone is binding to the ligand, or the hormone ligand is binding to the receptor to initiate, trigger, induce signaling or signal reception. You're not making a statement here, you're talking about it. Okay, so the hormone ligand is binding to the receptor on the outside of the membrane, obviously not getting through because it's stopped on the outside. Once it's bound, it's going to signal the next step. So some sort of explanation of what is happening here. Binding to the active site. And then we have, for step 2, we have a transduction pathway. So you could go into anything about second messengers, a signal transduction pathway where we could have CAMP, right? Is our second messenger. Binding here, once it's activated, it is moving through the cytoplasm, changing shape, okay? And then in step 3, we have our final molecule. Maybe this is going to open DNA, right? Maybe this could be a signal molecule starting a gene. So once this binds, what happens when we start gene expression? Don't repeat that gene expression happens because that's here. You have to tell me what is happening, right? So gene expression means transcription and translation, that we're building a protein. Okay, so transcription and translation are happening. That would be more of an explanation for this. So we have to be really careful when we see these bolded words explained. That should be at least 2 sentences per thing, right? All right, question 2. Compare. Okay, that's a little easier. Compare a steroid and a protein. Well, steroids are, a lot of you got this question right. Steroids are nonpolar, so they can go through the phospholipid bilayer. They can pass through the lipid tails. They're hydrophobic, right? Meaning they can go straight across that membrane and then go into the nuclear membrane, right? So it could go to a cytosol receptor, going inside and affecting a nuclear response. So proteins typically will not pass through that phospholipid bilayer. They won't go through the tails. They're too big. So they're going to bind to an external receptor, kicking in that second messenger, right? Or they're going to have some sort of transduction pathway because they can't get through that membrane. Okay, so this was a 4-point question. Question 3, a lot of people just basically made statements on this one. So hold on one second. Daisy Girl's getting crazy. Hold on one second. You crazy doggy. Daisy Girl, come here. Good girl. Good girl. Okay, so for this one, it says explain how the gas-Dermin pore formation and interleukin release contribute to the organism's defense against a bacterial pathogen. So first of all, we've had this question on a free response before. So this pore formation is going to allow, a lot of people were thinking that pore is going to open up and then the interleukin is going to go through here. No, that's not what's happening, right? Interleukin's going through over here. So this pore formation allows water to rush in because the cell is hypertonic to the environment, right? Once that water rushes in, what happens to the cell? It lyses, pops open, right? An explanation of maybe the tonicity of the cell. Why is water rushing in? You can't just say cell lysis destroys it or prevents the bacteria from replicating. That's not an explanation, that's a statement, right? And it's directly from the scoring guidelines, which is another thumbs down. Interleukin will stimulate immune cells in the immune system to destroy the infected ones. So you need to talk about this. Interleukin being released from the membrane is stimulating the immune system, period. The immune system then harvests an attack on a bacterial cell and gives some sort of an explanation of what's happening. All right, next question, number 4. Describe. I should be seeing at least 5 to 6 sentences, right? The effects of inhibiting step 3 on the formation of pores and the release of interleukin. So if we inhibit step 3, okay, if we, and repeating this stem does not count as part of your sentence, right? So your sentences start once you've gotten past this. Okay, so inhibiting pore formation. So um, if we stop step 3, that is going to inhibit pore formation. And you could say step 3 is activating the N-terminus gasdermin, and refer to the diagram. Show them that you're looking at this. Okay, so inhibiting step 3 causes this cellular response of creating pores. Well, if you inhibit that, the pore formation is not going to happen because we've interrupted this pathway. A description would definitely be tying this into their thing. Step 3 has nothing to do with here. So because step 3 is a separate pathway from step 2, interleukin is still activated. And if interleukin is still activated, what does that tell us? The immune response is still going to happen. Okay, so a description is not stating these two things. So I saw a lot of pores will not form, period. Interleukin will not be affected. Or interleukin can't get out. And interleukin is not going out of the pores, interleukin is going out of the membrane. Okay, so that part is not affected. Okay. All right, question 5. Last one. Make a claim and provide a reason. That could have been 2 sentences. So make a claim about how cleaving inactive capsase results in the activation of capsase 1. Well, if we cleave this, maybe this was a repressor, maybe this was an inhibitor, and I think they even said that the black dot was removed, was given a point. Okay, so cleaving that is going to activate this. Okay, you're removing an inhibitor, repressor, something of that sort. And then what would be a reason? So the student claim, hold on one second, Daisy is going the crazy girl, hold on. All right, these dogs are crazy today, having a wrestle session. Okay, so a student claims that the pre-infection production of inactive precursors shortens the response. Well, yeah. What would be a reason? So if these were already made and sitting here, and this is a protein, what would the cell not have to do prior to infection? Well, it wouldn't have to transcribe and translate the genes to make this protein, right? You can't just say, this was a big thing this year for grade A, you can't say because it's already there, because it's there. You have to say that the cell is saving time by not having to turn it into a protein through transcription and translation. Okay, hope that's helpful. If you have any other questions, shoot me questions in Remind. I am very proud of the responses I've been getting, and you guys are really sticking to this. I'm glad, and I will see you in the next video.